Record. Okay, so this is going to be chapter 2 today. But I changed some due dates, so if you go on down, you'll see chapter 1 is still due on the 2nd. Chapter 2 is now due on the 4th. Okay, now I went through and redid the discussions. In the past, discussions, like say discussion 3 would have 2 or 3 topics inside of it. So in one discussion, we had to talk about 4 or 5 different things. So now I just broke them all up into separate discussions. So like in week 3, for instance, there's 2 discussions. So there's 1 topic in each. Before, it was 2 topics in 1 discussion. The reason I separated it out is when I move this to an 8-week format or 16, I have to be able to move the discussions around. Okay? So same amount of discussion topics in there, just each one has 1 topic now. Okay? Make sense, everybody? So week 3 is now due on the 11th. So again, these dates only pertain to spring 2019 first 8 weeks. Okay. Now, next week, I will not be here. Okay?
What?
So there's already a recording up there for chapter 3. So you watch that one, okay? I will have email access, but can't guarantee much beyond that. Okay. So y'all know what's due for next week. Now, let's go back to week 2. That's where we are today. The labs. I was talking to William back there, and I think Summer asked me a question about it. Wireshark, for instance. You don't technically have to do Wireshark in the virtual lab. Because really it's just showing you how things work. Like if you want to scan a different server from your own machine, that's fine, but still make sure you understand the concepts. Because they're actually doing a really good job explaining some of the concepts. Like NetBIOS and stuff like that, that's an amazing concept in there. So go through it all, but really the only thing that's graded is the questions at the end. So it's up to, I still want you to go through them because it's a very good learning process. But, if there's issues, there are workarounds to it. Okay? Make sense? So has anyone done any of the labs yet? A couple of you? Okay. I still have to figure out how they get graded, but I can't do it until someone finishes it. I know they appear on, they appear on MindTap for you to look at. Right. Yeah, you have to click on the screen. You have a question? Oh, go for it, yeah. You got to click the screenshot button. Even if you don't take a screenshot, you must click it. And that gives you credit. That's kind of weird. But then you get graded on the questions. Now, I've talked to Cengage. The questions are graded, but they can't guarantee me how they convert into my grade book. They're like, we don't know if they happen immediately, or we don't have them at the end of the semester.
It takes about 5 minutes. Yeah.
Okay. So they do appear inside of Canvas.
My score is on there.
Okay. Okay, good. Because I asked them, we don't know that. I'm like, it's your system. But I was hoping, some of you finished and then we could find out. All right. So today we're going to cover chapter 2. But before we cover chapter 2, I'm going to do something, and I'm not going to put it online. But it is going to be in part of the recording. I want to cover some questions. I want you to write the answers down. Write the answers down. You ready? Oh, put them in a notepad or something. Just ABC. Okay. Now, the goal of this class is what? Well, to get a grade. To hopefully pass your CEH exam. Certified Ethical Hacker exam. Yes.
So, when applying for the CEH exam, you have to meet some requirements. But if you take the class now, you won't meet those requirements.
You won't meet them?
That's my assumption.
I think you will, because I took it. Yeah, but I don't know if I had to prove anything.
Oh, okay.
I don't think I had to prove anything. By the way, I took mine via ProctorU, so. But I did go to a class as well.
You're talking about CompTIA, right?
No, we're talking about CEH, EC Council.
Okay.
CEH, Certified Ethical Hacker, which this class is basically about. Now, I have a very good test bank, which I'm going to show it to you right now. Here's question number 1. Black box testing. The black box testing methodology enforces which kind of restriction? All of these questions are from chapter 1. Okay, don't call it out, just write down your answer. So the black box testing methodology enforces which kind of restriction? Only the internal operation of the system is known to the tester. The internal operation of the system is completely known to the tester. Only the external operation of the system is accessible to the tester, and the internal operation of the system is only partially accessible. Write down what you think your answer is. Don't tell anybody. Okay? So Jeopardy. Okay. You have a 25% chance of guessing this year.
Just the letter or
Just write the letter. Question 1 is whatever. Okay? So I got an answer to you at the end. Question 2, white box testing methodology enforces what kind of restriction? Only the external portion is accessible to the tester. The internal operation is completely known. Only the internal operation of the tester is known, system is known to the tester, and the internal operation of the system is only partially. By the way, these were on my test.
what's the difference between B and C? I don't understand that.
Okay, B, the internal operation of the system is completely known to the tester. C, only the internal operation of the system is known. Okay. One is only the internal operation, known as they're close, but you know, sorry, I didn't write them. I did not write these questions.
It's supposed to be.
And I'm going to tell you, when you take certification tests, there's a lot of questions. You're like, this makes no sense. So what do? Make your best guess. Because there's a lot of certification questions that are never even graded. They'll even tell you, 18% of these questions aren't even graded. Like, well, that sucks. Gray box testing. The gray box testing methodology forces what kind of restriction? The internal operation of the system is completely known to the tester. Only the internal operation of the system is known. Only the external operation of the system is known to the tester, or the internal operation of the tester is only partially accessible. Whew. All right. I know they're confusing. Pick a letter. All right. As a certified ethical hacker, you are contracted by a private firm to conduct an external security assessment through penetration testing. What document describes the specifics of the testing, the associated violations, the essentially protects both the organization interest and your liabilities as a tester? Would that be the service level agreement, the project scope, the non-disclosure agreement, or terms of engagement? And they're all very wordy like this. Number 5, the internal organization. So the internal organization regulates billions of transactions daily and provides security guidelines to protect potentially identifiable information. These security controls provide a baseline and prevent low-level hackers. Prevent low-level hackers, something known as script kiddies, from causing a data breach. Which of the following organizations does this? IEEE, CDC, ISIO, or PCI? And, really, it's hard to figure out which question goes with this chapter, but these are kind of close to this chapter.
You're going to tell us the correct answer in a minute.
So how'd you do?
I got 4 wrong. I mean, number 4 wrong.
Those different, very different.
What was?
Oh yeah, let's go back through. Number 1 is C. Okay, black box testing. Only the external operation of the system is accessible to the tester.
PCI.
Payment card and no, PCI is wrong. It's C. All right, number 2. Number 2 is B. Okay, So white box, the internal operation of the system is completely known. In other words, they tell you how the system works. They tell you all about the network. And you're just going to verify, have the windows been updated, stuff like that. Okay? So number 3 is D. Only the external operation of the system is accessible to the system. Oh, did I? Is it D? Hold on. 3 is D. I'm sorry, my bad. Sorry. My bad. D. The internal operation is only partially known, hence gray. It's not white or black, so it's D. Sorry about that. All right, as a CEH, it would be a D. A terms of engagement. I might put the questions on the next slide next time. I just was typing them in earlier. And the internal organization is C. It should be the International Security Industry Organization, I think. Yes, correct.
The only one with international and organization.
What's D? Tell me what D belongs to.
Credit cards.
Credit cards.
Yeah,
Payment.
I just read transaction.
Yeah. I mean, PCI has been on a lot of tests, a lot of them. This is big. PCI compliance. I mean, I used to do it for a company. It's a pain in the butt.
PCI international?
What?
Is PCI international?
I think it is. Okay. That's the 5 questions I could find for Chapter 1. I got some for Chapter 2 as well, but you don't get to see them yet. Okay, let's talk about Chapter 2. But these are a very, 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 very good study guide. Okay. At some point, I'll just give them all to you. All right. So let's talk about TCP/IP. Okay. How many layers are in the TCP/IP model? Anybody?
No, 4.
4. What's 7? OSI model. See, we learned about the OSI model in networking. That was the plan. But when they actually went to implement, like, okay, we got this application, this presentation layer.
Ken, what about the modified TCP/IP model that like Cisco's starting to use, where they're splitting out the network layer to and it's more closely matched to the?
Yeah, that's not covered in this.
Okay.
Yeah, he does have a very valid point. They are changing it, and it makes sense because of the new technologies, and even IPv6 handles it different. So they are changing a little bit, but when they implement it, they base it. There's really only 4 layers. Okay, so let's start talking about this chapter. TCP/IP says a protocol is a language used by a computer to communicate. I remember years ago running Windows NT351. And I had to install, back then to get on the internet, you used SLIP or PPP. Does anyone ever remember those names? Serial Line Interface Protocol or Point-to-Point Protocol. And they came out with TCP/IP, and basically was on like 23 floppy disks. It was a million questions. It was, you had to know all this stuff. But nowadays, it's just there. Okay. Back then, when I took care of a network for a company called Aerospace Reports up on Rockwell and Northwest Expressway, another guy wrote a software program for them, which they loved, and he took care of the network. But then he was leaving, so he referred them to me. So I went there, and the guy's like, I really don't know anything about networking. It just works, which is a scary concept if you think about it. So I went there to look at their computers, and they have TCP/IP installed, which was required for internet. They also had NetBIOS, NetBIOS, AppleTalk, NetWare, all these. Basically, back then, when you set up your computer, you had to pick the protocol you wanted. He did select all. And it worked. Okay? Yeah. So it worked. So I looked at him like, oh my God. I mean, I said, this is crazy. What you really need, you need a client from Microsoft Networks, you need a TCP/IP, and one other one. File and printer share from Microsoft Networks. Whatever. I think there was 3 of them you needed. But I went in there to the owner, and I said, I'm not going to mess up his stuff, but let me look at it. And I went in their machine. I'm like, so I started deleting stuff. This lady's freaking out. Whoa, what are you doing? I'm like, I'm going to delete all this. You don't need all this. Are you sure? I'm like, yeah, I'm sure. Just let me delete them. So I delete all but what she needs. She's so nervous. So I go to the next computer and I do the same thing. And I do all computers in the office. Then she goes, she's like, what you do is like crazy fast. Because he had so many protocols installed,
Just checking all.
it was doing everything. It's kind of like, to be in this class, you need to know 18 different languages. And you need to, figure out how to talk. You two are talking Spanish and you two are German. And then we're, it's like, what the heck? So when I did that, and she's like, oh my God, my network is amazing. So they hired me, and so then I had the job forever. But really, a protocol is a way of communicating. And TCP/IP is a protocol suite. Includes a whole bunch of stuff. It includes DNS, FTP, SMTP, SMB, just all these protocols built into it. Okay, it's the most widely used. I'll tell you the truth, IPX, SPX, much faster. Much faster. What's it used on? Or what was it used on? Novell. Novell NetWare system. Super fast. But it's no longer a standard, so I don't think it's supported at all anymore. Okay, the 4 distinct layers. Network, Internet, transport, and application. And Greg online here knows so much more about the model than I do because he teaches all the Cisco stuff. So, Greg, speak up if I say something wrong, please. Okay. So we have the application layer, the transport layer, the Internet layer, and the network layer. I will tell you the test is not really in depth in this area, which is good. Okay. Well, I have to know a few things about it, but nothing too much in depth. Okay. So application says network services client software. So remember the OSI model had the presentation and application layer. But didn't my email take care of both of those? Doesn't Outlook handle it? So why have 2 separate layers? So they kind of combine them. So they combine a lot of stuff. Now here they talk about TCP and UDP. So the TCP model has TCP or UDP. TCP stands for Transmission Control Protocol. It's the connection-oriented protocol. So I want to talk to Ken over there. I do what's called a 3-way handshake. I said, hey, Ken. I sent him, a packet, and he goes, he responds, he acknowledges my SYN packet, my synchronized packet, and he sends me a synchronized packet. Then I acknowledge his synchronized packet. We'll cover all these more in depth. So it's a 3-way, but then we start talking back and forth. But we keep track of every single packet. Imagine going to the grocery store and you buy this huge cart of groceries. But when you're coming out to your car, it's broken up into separate bags. So if you drop the bag with eggs, you only have to replace the bag with eggs. So that's the way the network works. It takes whatever you're doing, breaks it into packets, send them separately across the network, keeps track of every one, and if one's missing, it only has to replace that specific packet. Okay, that's UDP, User Data Equipment Protocol, is mainly originally used a lot for printing and chat. It's kind of like, think of Netflix. Okay, Netflix is now TCP as well, but imagine Netflix. What happens if you miss one frame in a movie? It doesn't matter. So you really don't care as much. So it doesn't acknowledge every single packet. It's a lot faster. It doesn't have the overhead. It's basically, I just start throwing at you. Here, catch. Okay? But our networks are so reliable now, it still works anyway. Okay. So here's the application layer. Here's some of the different protocols in there. HTTP, Hypertext Transport Protocol. You need to know all of these. Okay? You should know someone from networking class anyway. HTTP is basically web traffic. Hypertext Transport Protocol. What port does that work on? Anybody? Port 80. You need to know the ports. They'll be listed in here as well. Port 80. File Transfer Protocol. Still used today. Not as much because it's really not secure. File Transfer Protocol works on ports. Okay, that was good. Works on ports 20 and 21. One's the dating, one's the command and the data protocol. It's used for transferring files. Well, think about it. When we first came out with this, I mean, they got the internet to work. They're like, oh my God, it works. They really didn't care about doing it the right way. Okay? It's like, I'm having my house remodeled. Yesterday, they came out to do the final electrical inspection. They failed it. Because when they did my new dining room, they did put it on a separate circuit. We're totally done. Everything's painted. Everything's 100% complete. Now they got to rip the wall out to rewire the dining room. You're not a happy person. So basically, they didn't do it right. So basically, FTP, they made it. It worked, but it wasn't secure, so it's not used as much. Okay. SMTP, Simple Mail Transport Protocol, port 25. Okay. Used for sending mail. Okay. SNMP, Simple Network Management Protocol, port. I can't remember. I can't remember the port. Oh, well, not used as much anymore. I can't remember. It's in here. I just off the top of my head. But it's okay. I used to use it to keep track of my traffic on my network. I ran my ISP. I could track and see exactly how much data each website was generating. Okay, so it's used for managing your network. Okay, SSH, a secure shell, a secure version of Telnet. Telnet's not even. Oh, Telnet is listed. SSH uses port 22. Yeah, 22. Okay. Yeah, 23 is Telnet. Yes. Okay. IRC, normally like 7001, but it really can use anything. But IRC is Internet Relay Chat, so it can use a lot of different ports there. So those are just different applications that work over TCP/IP, and there's lots more. Okay. It says it encapsulates data into segments. We break our data into pieces. So we take our data, break it into pieces, then we add headers to it so it knows where to go. So connection, TCP is connection oriented, which means the sender doesn't send any data to the destination unless the destination acknowledges it. There's also something called sliding window. Does anyone, I bet no one in here ever used a 2400 baud modem? One of you do. I learned on a 300 baud modem. No, it wasn't quite that bad. But I learned my first network class was at Longstool. No, that wasn't. No, it was it began with K. Whatever. But I remember I learned networking in your room, similar, big room, computers on one side, computers on the other. We would type a message on one side, walk around the room, and watch them appear one after another. That was 300 baud modem. Okay. Then we got 2400 baud and 96, and we went crazy. But there was something called the sliding window, where I would send Ken one packet. He got it successfully. Then I would send him two. Then he would acknowledge him. Then I would send him three. We keep going faster and faster, more at a time, until Ken's like, whoa, I didn't get that last group. So I'm like, okay, you couldn't handle 10, so I'm going to back down to 9. Okay, it's kind of the way that works. Okay, here's that three-way handshake. So computer A says it was called a SYN packet, synchronized packet. Okay, so I'm going to send a packet to Ken. Hey, Ken, I want to talk to you. So Ken acknowledges that with an acknowledgement packet and sends me a SYN packet. He goes, all right, Ken, I heard you, and I would like to talk to you too. Okay? Then I say, all right, Ken, let's talk. That's our three-way handshake. Okay? We're going to learn about different problems with that. Okay? There's a lot of, SYN attacks. Or what would happen if I sat there and said, hey, Ken, I want to talk to you? Over and over and over. Way back when I worked at an ISP, we bought out this ISP that went bankrupt. And they kind of messed up the shared secret of our nationwide dial-up. So the moment we took over the system, the calls started coming in. And I still remember that day. We were sitting there in the office. All voicemails were full. Every phone was ringing. We have a nationwide dial-up, and we couldn't do nothing. So we just sat there. Imagine me keep calling Ken over. Soon he's going to get tired of answering the phone. Sooner or later, he's in that. So that's the SYN attack. We'll talk more about that later, too. Okay. Headers. There's a lot of components. We're going to see a picture of one. There's flags. There's sequence numbers. There's actually even attacks you can use on some sequence numbers. There's source and destination ports. Okay? They can be abused by hackers. You need to know some basic hacking to protect your network, and we're going to talk about that. Here's an example of a TCP header. We have a source port, a destination port, each 16 bits long. We have a sequence number that's 32 bits long. It starts off by someone selecting a random 32-bit sequence number. Then every time I send Ken another packet, that sequence number increments by 1. Since it increments by 1, we can now, if the packets arrive out of order, we can put them back in order because we know which order they go in. Okay. You also have a bunch of flags. U is urgent. A is acknowledgement. P is push. R is reset. S is send. F is fin. Okay. Those are flags. We can talk more about those as well. We have a window. That's that whole sliding thing. How big is our window? You have checksum. Checksum is error checking capability. Okay. Imagine me doing a mathematical calculation on every packet. So I create this packet. I do a mathematical calculation. I send it over to Ken. He does the same calculation. If the packet's in good shape, they should match. So when I do the calculation, I attach it to it, send it to him. He does the same calculation, checks it, numbers don't match, doesn't acknowledge the packet. Okay. Urgent pointer, not used much anymore, but way back when, you can say, this is an urgent packet, this is not. Okay. There was also other options in paddings as well. Here's some of the flags. Flags are binary. They're either on or off, 1 or 0. Okay. SYN flag, for instance. When I send him a SYN or a synchronization packet, the SYN flag is set to a 1. So he knows it's a SYN flag. So when he replies with SYN ACK, then the SYN would have a 1 and the ACK would have a 1. Okay? Then when I replied back to him with just an acknowledgement, obviously the SYN would be 0 in that case and the ACK would be 1. So flags are how we turn things on and off. Okay? They can also be used maliciously. For instance, the push flag or the urgent flag are not used much anymore. There's a program out there called HPing3, which I don't know if we're going to use. With HPing3, you can force packets to do specific things. Like I could force packets to use the push flag. Imagine that. So I'm going to send some hidden data to Ken. And I'm going to encode all of it in the push flag, 1 bit at a time. It might take a while. But if he's receiving packets and only reading the push flag, it's kind of like getting Morse code. And he could literally just read the push flag from each one and reassemble the secret message and do stuff. So just, kind of cool stuff. So the initial sequence number is a random 32-bit number. They're not truly random. There is... I don't know exactly what it is, but there is some stuff on how it started. Okay. It tracks packets by node. So in other words, I start with a number. Every time I send Ken another packet, I increase it by 1. Okay? It allows us for reassembling on the other end. Okay? Set on steps 1 and 2 above. And then they keep going from there. And there's one called the initial sequence number guessing attack, which is a definite vulnerability. It's from years old. But there's actually still a lot of systems. When I took care of Anytime Fitness, their gym system, the digital video recorder we used in all the gyms had an issue with it, had a vulnerability for the initial sequence number guessing attack. And every time we tried to do our PCI compliance check, we would fail. It's like, whoa, you failed the initial sequence number guessing vulnerability. Well, they won't fix it. They even told us they're not going to fix it. But the DVR was not on the same system as the credit cards. So I had to explain that every time. I'm like, no, that's on the DVR system. That's a totally separate system. It's not connected to the same area, so it's not a problem. But it literally was a pain in the butt every time we had to do that. Okay. Ports. Think of ports like your TV channels. Okay. So port 80, I'm going to surf the web. Port 25, I'm going to send some email. Port 23, I'm going to use Telnet. So packets cruise across the network. There's a video we're not going to watch tonight. It's called Warriors of the Net. Anyone ever seen that movie? I'll show you where it's at. We're not going to watch it tonight, though. Warriors of the Net. It's called, I think it's Warriors of the .net. Yeah, there it is right there. Warriors of the .net. Kind of a cheesy video. Even has the dreaded ping of death in there. It shows you how it works. So packets are cruising across the internet. Depending on the port, it decides what to do with it. I mean, up until recently, we have cable modems at home. That cable had all the channels on it. Then you just needed the box to, change it. Now it's changed. I don't know if y'all realize that. Originally at much higher speed now, as they're technically really only sending us the one channel we're requesting. Because initially they used a lot of bandwidth download, to our houses, a little up, and there wasn't, but it's changed a little bit now. So, ports are logical, not physical. In other words, it's not like a separate door. It's just, they're each labeled. Think of it's labeled. So this bag's labeled eggs, so it goes in there. This bag is labeled bread, so it goes over there. Same kind of thing, okay? So an example, HTTP uses port 80. So the packet cruises out the internet, labeled with port 80. My web browser says, whoa, that's for me. Okay. It says, helps you to stop or disable unneeded ports. So basically on your system, you should go and disable. Did I show you guys GRC last time? Okay. Did anyone run that at home? Go to grc.com, run Shields Up. If you haven't done it, I'll tell you what. If you do that, prove to me you did, I'll give you extra credit on something.
Little snitch is what you use from that.
Little snitch. GRC should still do it, though.
It's not
from the first day.
Little snitch is neat because you can prevent your computer from reporting back to Microsoft of pirated software.
Oh, handy. That's nice. But grc.com, if you use GRC, go to grc.com, go to Shields Up, provide me proof you did it, and a screenshot, something. I'll just give you extra credit somehow. Okay. Basically like the last point, when in that first network I was telling you I took care of their network, they had every protocol running. So they had every service open and running. When I finally turned them all off, it's just like, the load was much lighter. It could function a lot better. Okay, that's why you want to get rid of stuff you don't need. But I will tell you, if I went into my machine right here and I brought up Task Manager, and I looked in here, it's all these processes. What the heck is all this stuff? I don't want this RAV BG64. Anyone know what RAV BG is? I don't know what it is. I'm the kind of person, I just start turning stuff off. Guess what happens if you turn off the wrong thing? You're rebooting your machine. So a lot of times when I'm trying to get rid of viruses, I'll do that. I'm like, what's this? Well, shouldn't have done that one.
You can also right-click an open file location.
Yeah, sometimes. Not always.
It's just Google search.
But the problem is, like, sometimes there'll be a system. Where's it at? I know it's got to be running.
And if it's like in system 32, then it's probably fine.
Yeah, but sometimes viruses hide in there.
Yeah, some sure.
Yeah, sometimes it's hard, but you can try to close some of this stuff out. I mean, this app's gotten a lot better than it used to be years ago. So, all right, let's continue on. Okay, TCP ports. So the first 10 or 1,023 ports are considered well known. So how can I find? Does anyone know an easy place on this machine to find out what port's what? I'm going to go to C, Windows, System, 32, drivers, etc. No, I'm going to open up services. Look at that. Look, FTP data is 20, FTP is 21, SSH is 22, Telnet's 23. Look at that. Isn't that handy? So what was that? I was looking about SNMP.
It's 161.
161, right there, SNMP 161. Now, you can remap these. I used to run a consulting business, and I did a lot of work from here. And I needed port 3389, which is, anybody? RDP, correct. I needed RDP right here. I needed remote desktop protocol. Rostate blocked it. So I remapped the port to 21, FTP. So I went into my software and says, no, don't use 3389, use port 21. So I would, all day long, be remoting into all my clients and everything, no problem. And our network guy came over one day and goes, so, and you do a lot of FTP. Yeah, because it's not bothering me any. So, yeah. So if you know what you're doing, you can change these. But you shouldn't always change them. So, all right. So first 1023 are well-known stuff. You can go to IANA to find out more about them. Here's FTP 2021. Now let me show you an example of what FTP is. Can y'all see that maybe? FTP to FTP.nei.com. Network Associates. I'm going to log in with Anonymous. I'm going to be ken@here.com. There you go. I'm logged into a remote FTP site where you can download virus signatures for McAfee antivirus. So I can do a list, and I can change into their products. I can change into download test. They changed it. Let's go back. Let's go to spam definitions. Oh, no, I want virus definitions. Okay, there I'm going to 4.x. There you go. I can see the latest version of their DAT file. So this is using the FTP protocol, using port 20 and 21. I made a connection to their system. I logged in. Now I'm getting a listing of files. Now I can literally tell it to go into binary mode, and I can say get 915. 1x stat.exe. There you go. Now I'm actually, wow, that's a big file. Now it's actually transferring that file to my computer. And if I had that antivirus running, I could then use it to update my antivirus. So FTP still has uses out there. I can stop it. I can do, say, buy, and it's gone. If I look, I do dir, yes, and it didn't finish transferring. So you have to know some Unix commands to use that. But so that's FTP, File Transfer Protocol. You will need to know majority of these ports, just so you know. Okay, it says, was a standard for moving files years ago, still used a little bit, but not as much. It requires a login and password, but the problem is that's passed in clear text. So when I logged in there with anonymous and stuff, anybody in the world could have seen it. So we'll talk more about that another time. Actually, when you do lab 2-1, it'll talk about connecting to with port 80 or port 443. Port 80 is just like 20. It's not encrypted. See, I don't think Wireshark's on here, is it? No, so I can't show it to you on this one. So. All right, here's an example of FTP. Mine was just cooler. He's just doing inside of his browser, which you can do as well. Port 25 is email. Simple mail transport protocol. Email sends on port 25, receives on port 110 if you're running POP3. But so email servers listen on 25. Okay. Port 53 is DNS. Now the problem with DNS is both TCP and UDP, but TCP is normally the answer for that. Domain name services. So when I type in www.google.com, am I really connecting to www.google.com? No, I'm connecting to one of those numbers. Now check this out. Watch them. See how they're changing? See how they're changing? What's that called? It's called round robin. So what that's telling me is in this area, Google has 1, 2, 3, 4, has 6 different servers running. And every time someone hits it, alternates which server it goes to. That way, if one goes down, no big deal.
Why doesn't it slow down?
The IPv6 does it its own way. I don't know exactly how it works. But yeah, the exchange, it's like load balancing. They can bring another one on, take one off without a problem. Yeah. Kind of a cool system. There's a book out there called In the Plex, which talks all about how Google works. So we all know what Google is. Does Google buy expensive or cheap hardware? Cheapest you could possibly buy. They buy the stuff people throw away. Their system is set up so well, they expect failures. So they just throw it away. No big deal. It is fully redundant. Stuff crashes, no big deal. Just picks up instantly. Yeah, and it's crazy. And they're actually, I just read another book, a real recent book. They're showing how RAM is like 1,000 times faster than a hard drive. So Google is starting to no longer use hard drives, store it all in actual RAM, not even SSDs, but because it's actually faster. I mean, if you can get 1 millisecond increase in search speed, why not?
they're storing the data in the memory space.
In RAM, yeah.
Yeah,
They're building their own kind of RAM to store this. It was just read it.
Ken, are they doing like we used to do RAM drives?
Yeah, exactly. The old RAM drives. But Google is making their own proprietary RAM, which is everything's in it. Because you get rid of the moving parts of the hard drive. They're no longer spinning. And it's, what, 10,000 times faster. So,
Not solid state where it's there's a
not solid state.
where there's an actual
No. What the heck was that book? Try to remember the name of the book, but it was really interesting. It was talking about that.
Very fast.
Yeah,
You
it's
could use that for
crazy stuff.
permanent storage.
All right, so let's continue on. So, port 69, trivial file transfer protocol. It's used for what thing mainly, Greg? Come on, Greg.
Uploading Cisco binary files.
There it is. It's normally used for uploading Cisco IOS or their binary files for your routers. Not used too much other than that. The difference between port 2020, regular FTP and TFTP, regular FTP, you log in, you transfer files. TFTP, you kind of give it the whole command all at one time. Hey, my name is Bob. Here's my file. Take it. And it logs me in, transfers files, and it's done. Kind of all done at one time. It's kind of the short version of it. Transferring router configurations. Okay, port 80, Hypertext Transport Protocol, HTTP. It's used for connecting to web servers. Okay, port 443 is the secure version of it. Okay, I set up years ago all the wireless for all the Buffalo Wild Wings around here. You know, Moore, Edmond, all those. I set up all those wireless, and I did it for years. Basically, I set them up, and they would pay me a monthly fee. Now, after about 5 years of having one service call, I just stopped billing them. I felt so guilty. I'm like, they never call me. Because what do? You reset the router. I mean, you reset the router, it's fixed. So I just stopped billing them. I don't even know who's doing now because they would never call me because they would never breaking. I just couldn't keep taking the money. But so if I'm setting up wireless and I want to have wireless that's pretty secure, what ports do I need to have open? So if I'm going to set up wireless for Buffalo Wild Wings, obviously we need port 80 so people can surf the web. But I want to block out stuff they don't need. So what else do I need open? 443, maybe we want to do some secure web surfing. What else? Is that all we need? That,
You need nine, whatever the secure.
Google wasn't out there yet at that point.
Okay.
So we don't need the 900s. 110 if they want to check your email through POP, which no one really does anymore.
143.
We didn't do IMAP. What else? Anybody?
143 for IMAP.
Okay. 143 for doing IMAP.
139. I mean, you want to shut 139.
Yeah, we don't do 139. But pretty much that's what I did. It didn't work. What am I missing? So I was like, what am I doing? God, I'm stupid. So here's how I tested it. I said, okay, let me see if the networks, I went 66.210.163.130. Oh, it's changed. Okay. That used to be I used to own that company on that address. So I checked and it came up. So I'm like, wait a minute. So it works. So I could go there via number, but I couldn't go by name. So what am I missing? I forgot DNS. I'm like, oh, what an idiot. So I enabled port 53, boom, fixed. So what I did was I went into the router. I blocked up to 52. Then I blocked 54 to 79. You know, I had to block and just allow just those open. I'll tell you, it worked. And for 5 years, I got one call. And the one call was they just didn't know where the power was to reset the router. I just felt so guilty. So, all right, so let's continue on. So there's 110, 119, network news protocol, not used a lot anymore, but it is still there. 135, remote procedure calls, and these a lot from mail exchange type stuff. 139, NetBIOS, you really don't want that open. You really don't need NetBIOS anymore with TCP, but a lot of places still use it. 143 is IMAP. Okay, so a lot of different ports there. Okay. So how about UDP? Fast but unreliable. Again, instead of me making that three-way handshake where they're seeing an act with Ken over there. I'm just going to start throwing stuff at him. Here you go, Ken, catch. And hopefully he catches it, okay? Use for speed. Does not need to verify if you're receiving or not. You're like, I hope you're ready. Use it a lot for printing. Just dump it on the printer. Here we go, okay? Higher level really doesn't handle, any, connection type. I said it's a connectionless protocol, okay? Just not used as much anymore because the network's fast. So, all right, the internet layer says routes packets to destination addresses. Use a logical or an IP address. Okay, is connectionless. Think of it like this. So I take a letter, those square rectangle things at your house? They're getting ready to up the price. Letters. Yeah, but it's like, why? I mean, I bought a Forever roll of stamps like 10 years ago. I think I've used 5. So I think I'm good forever. But, so I put an address on there. Okay? What part of that makes sure it gets there? Is the address the part that makes sure it's getting where it's going? Right. The IP part, the address does not, oh, it's got an actual letter. The address, the IP part does not guarantee delivery. The post person, the postal system, or TCP is the part. So when you got TCP IP, let me draw this awesome picture here. So what the heck did I just do? Note. Oh, if I type TCP, UDP, okay? And under below that, I would have IP right there, see IP. So basically, IP is the numbering, the IP address. Doesn't mean connectionless. It's basically, that's the numbering. So he writes that letter correctly over there, fills in the correct address and everything. Does that guarantee he's going to get there? No. Because whoever the person, whenever my mail lady goes on vacation, we have this thing, and they're like, okay, who's got my mail? Because the temps suck. They just deliver it wherever. Some Amazon delivered a package the other day to actually my next door neighbor and put it on the front steps. Well, this guy lives by himself. He always goes in and out through the garage and never goes to the front door. It was out there for 4 or 5 days. Somebody else is like, does anyone know where my package is? And finally, our mail lady came back from vacation. He goes, oh, sorry, your package is on Dick's front steps. But so really, it's the person. So it was addressed correctly, but it's the person to make sure it gets there. Okay. So an IP address is connectionless. Okay. You kind of think, oh, I put the right address, but that necessarily doesn't mean everything. Now, I used to work at a building 284 on Tinker. Kind of weird. I was a network person. I was actually a jet engine mechanic, and then but a whole little story. But they put me into the networking shop because I had a degree, I had certifications, I knew what I was doing. So the captain stuck me in there. And you can imagine those people in that office. Did they want me to be there? No, they hated me. He's like, this guy knows everything. Basically what he told them. So that sucked terribly. But this one office, building 210, was having this problem. The network shop could not fix it. So they're like, Ken, if you're so smart, you go fix it. So I went over there. I was like, their machines. And they got it. The IPs are all set up correctly, but there's something called a subnet mask. They're all different. They're like, oh, it doesn't matter. Just put whatever you want. I'm like, no. A subnet mask is like a zip code. So it's like, no, you can't do that. I said, well, let's try making them all the same. Not just the same, how about correct? Amazing, the network came right up. It was amazing. And then it was funny because a while later, I went on vacation. I went on leave for 30 days. I was in the military. They had another problem. So they called the network shops. Can't do you there. Nope, he's on vacation. We'll wait. They waited until I came back. I'm like, seriously? So it's funny. But just because the IP address is correct doesn't necessarily mean it's going to work. Okay. ICMP, Internet Control Messaging Protocol, is ping. Stands for Packet Internet Groper. It's basically, did it get there or not? It has a bunch of return commands, and I can actually bring up ping. I can take ping BS-104-01 right here, and what it's doing is it's sending a packet, 64 bits, I think, but no 32. 64 bytes. Over there, and I actually sent it to the wall, upstairs to room 207, to the router. That router sent it over to my office right over there. Then my computer says, got it. Send it back to the router, and it did that 4 times. And it took basically less than a millisecond to do each time. Okay? So that's one thing you can do it. Now I'm going to try pinging my house. DOA.mind.new, because I have my own DNS for my house. It's working? Are you serious? They enabled ping. That didn't work just the other day.
Yeah, I thought you said they disabled ping.
They did. They had to say, then maybe you re-enable it. That's weird.
So you pay for dynamic DNS? Or do you just
Okay. There's a company, Dynamic DNS, or the dydns.org or something. Many years ago, see, I'm one of those people that if I use your service or buy your software, I pay you for it. I paid them back in, wow, mid-'80s, paid them $20, and I got full pro service for life. I have never paid them another penny. Now they charge you, I think, for one address.
Yeah.
I have like 20, and they're forever for free. I'm like, okay.
I've looked into dynamic DNS on the web server.
Yeah, I've been using them forever. So now I'm going to use traceroute and see how to get to my house. See if traceroute works. I can't believe they actually got ping working. That's nuts. That's bizarre. And how? Why? This never worked. So, this time I tried traceroute. I basically said, trace the route from here to Ken Dewey's house. What I did was I sent a packet to Ken Dewey's house. But there's something called the TTL, time to live. Normally it starts either 64 on a Linux-based system or 128 on a Windows-based system. Well, what happens is traceroute sets it to 1. When TTL, or when time to live expires, when it gets to 0, it drops the packet. It basically says, you're done, get out of here. So it sets it to 1, sends it out. It gets to the first router, which is upstairs. The 1055 is upstairs. Then it comes back. Then I send out a second one, send it at 2. It goes through the first router to the second router, expires on the second router, then comes back. Then I send it to 3 and 4 and 5. It's not going to be a lot of names, but you know. So ping's working, but traceroute is. Yes. Yeah. So, but it's you know, still can't believe ping's work. That is crazy.
So is it hitting a wall after the second wall?
See, a lot of times it doesn't return the address. It doesn't return the host information.
Wait, so you have a permanent, a static IP address to read my name?
I have a static name.
Yeah. So his IP address will change, but the name will always point to the address.
You know, Ken, if you actually run that with Wireshark, the ICMP types and codes will give you more information about why it doesn't come back.
Yeah, the problem is on this darn machine I have Wireshark installed. But yeah, if you do that Wireshark lab, just do like I did, traceroute to do it on my new, and it'll show you. It's probably going through Dallas, maybe. I don't know where Cox is going through, but yeah. But no, you can't. There's nothing.
Maybe it's more
Yeah, I think I got all my ports closed right now anyway. But if you want to, go home and scan my home. Dewey.mind.new. That goes straight to my house. All right. But yeah, what Greg said, if you run Wireshark, it will actually show you those TTL. It'll give you the return codes. It'll say, you know, expired or whatever. So, okay. So there's traceroute. Oh, there's the return codes right there. There's request, reply, time exceeded, type code 11. So when it gets to the first router, it's exceeded because the TTL got to 0, it sends it back. It sends a return code 11, which basically says, hey, I'm out of time here. So kind of cool. All right, and there's the rest of them. IP addressing consists of 4 bytes divided into 2 components, network and host address. Originally, they were designated as ABC, and they also have D&E, multicast and experimental. Because remember the old original plan, 640K was plenty for everybody? Now, I remember building 230 at Tinker. I helped install a thick network. Used to call it frozen yellow garden hose. The cable looked like a frozen yellow garden hose. And you had to put a vampire tap over the cable every so many feet, like I think it was like 3 feet minimum or something, whatever it was, then that connection will get out to your PC. And you can have no more than 100 on your entire network. Yeah, we installed that. Then we replaced that with ArcNet. ArcNet was BNC type cable, and you could have no more than 255 computers on your network. So I mean, stuff they got now is phenomenal compared to back then. I mean, it was crazy. But the original plan was, A, for really large networks. Okay, give me an example of a big network. No, Tinker's a B network. Tinker's a middle network. Governments, yeah, but not an individual base. Or like Hertz. Hertz is a nationwide company. Cox is also a huge network. You know, now Class A networks are for like 1 to 126, I think. I can't remember the exact number. They might have them listed here. There they are. Wow, I was right. 1 to 126. So if you look at an IP address, so if I look at nslookup dewey.mine.new, my address is 68.229. So where does my address fall in that list? It's a Class A. I got a big network. No, I don't. I have very big. But my provider is Cox.
Yeah.
So Cox is a big network.
I think they have like, usually when I check mine at home, it's like somewhere between 66 and 69.
But look, on the Class A networks, there's only 126 in the entire world, but there's 16 million addresses on each one. Class B networks, between 128 and 191, 16,000 of those, and there's 6,500. Class C networks, 192 to 223, with 254 in each. So that's what the original plan was. No, they don't do it anymore. Actually, there's no more IP addresses. They ran out in like 2013 or 2014. They're all gone. But years ago, I wanted to run a network in my house. So I live I-40 Chateau Road. Dobson or Logix is my phone system. So I contacted them to install a network for me. And they couldn't do it basically because they couldn't install it in a residential address. Even though I was signing for a business account, they wouldn't do it. Some deal that, well, if I didn't pay my bill, they wouldn't have the rights to come in and steal the equipment back. So I contacted Cox and got service with Cox. The Cox called Logix, told them to go ahead and install it. So my system is still through Logix, but it's Cox. Because they still, I mean, they're not, Cox is not going to run a new phone line all the way, a new cable all the way to my house.
They're just like piggybacking on.
Right, they're piggybacking on Logix. So it was kind of funny the way they did that. But all right, let's continue on. So there's the different classes, okay? An IP address is composed of 4 bytes in an octet. A byte is 8 bits, okay? And if we bring up a calculator, for instance, my address was 69. If I go in here and do it programmer, so I had a 69. That in binary is that. Okay, we're going to learn how to convert that here in a second. Sometimes it's fine 4 octets instead of 4 bytes. So the Class A network, the first bit is reserved for the network. The last 3 are available for the host computers. So the 69 number there we saw is basic. Well, in this example, well, no, that's not the one. We need to look at the other one. Where's mine? Darn it. There it is. Okay, the 68 right there, the 68 would be the network. Then I am computer number 229.213.147. Because remember, Class A, small number of networks, but there's large numbers of computers on them. Okay. Class B divided equally, about 65,000 approximately. Class C, the first 3 are the network, the last 1 is the host. 254 computers. Okay. So, yeah, okay, we'll get to the rest in a second. Now let's start with subnetting. Subnetting, think of subnetting like a zip code. So if I'm going to go over here and bring up Google Maps, let's go to maps.google. Can't type tonight. I'm typing my address. Oops. This doesn't mean come stalk me. So I type in an 8412 tree line. I could be in Talk, Oklahoma. I could be in Plano, Texas. I could be in Argyle, Texas. So you see, so 8412 is my house number on Treeline Drive. But where's that? I mean, 8412 Treeline Drive, the only reason it's defaulting to the top is that's the closest one to me. I mean, there's one in Salt Lake City, Utah. They're all over the place. So how do we know where? That's the subnet mask. That's how it identifies the network, basically. Okay? All right, so allows the network administrator to divide large networks into smaller pieces, into subnets. Okay, as the concepts are important. They're actually very important. I said, your network doesn't work if they're not right. Windows kind of makes it bad. You really can't type it in wrong anymore. If you try to type in a number that's not valid, it's like, can't do that. But, you know, so must be assigned to subnet mask, helps distinguish them from each other. Here's an example of an IP there's the IP address. There's this converted into binary. Then there's our subnet mask. Now, subnet masks are either 0 or 1. So in this example, 255.255.255.0, the first 3 octets are all 1 because 255 is all 1s. The last one's 0. So looking at this example right here, so this 0 is underneath the 16. So this whole first part, this 170, all this stuff up to this period, this is all the network, and this is machine number 16 on this network. So how that works? Now, if you go to my YouTube channel and search for networking, I got like 4-hour videos of all about networking. Okay, so the subnet mask divides the network from the host. Okay. Now there's something called CIDR, classless interdomain routing. They realize that, you know, this whole ABC thing is kind of stupid. So now it really doesn't matter anymore. So you use CIDR. In this example down here, 192.168.1.0/24, that means there's 24 ones. So it's 8 ones, 8 ones, 8 ones, and 8 zeros. So /24 is the same exact thing as that subnet mask on the second bullet there. Just a different way of displaying it. If you're configuring a Microsoft DNS server, you can actually put it in either way. Transfer easier for you. Now, years ago, I was configuring, I think, a Utopia router, and I had to put it in the CIDR. So it really matters on the equipment. Now, Greg, doesn't Cisco do like an opposite? What's it called? Not a.
Are you talking about wildcard mask?
Yeah, wildcard mask. Yes, which is kind of like the opposite, isn't it?
It's complementary, and you usually use it for ACLs and rather than subnet mask or than IPs.
Right. Okay. So
it says which ones can change instead of
right. And if you see, the problem is when looking at ACLs and look, you won't always realize, but sometimes like, no, that won't work. Then you look, and like I said, it's a complementary. It's a wildcard mask showing what parts can change and what parts can't. So it's just a little different. But CIDR, easy to manage. So /27 means there's 27 ones. So how many zeros are there? There's 32. So there's 5. So 26. Because remember, there's 8, 8, 8, 8. So 8, 16, 24, 32. So 27 would have 5. Is that right? 5. Yeah, 5. I can't count. Okay. Okay. Planning a network address. Says each network segment must have a unique network address. Now, 10, for instance, what we have here at Rose State, that's an internal only number. Well, it's internal to Rose State. That's fine. But did Rose State have to go with 10? No, they could have picked whatever they wanted. Okay? Your home is probably 192.168. something, I'm assuming. Does anyone have that at their house? I got a new system called an Eero system. So I kind of like, except it's idiot proof. I cannot select my own network ID. That kills me. It's hard coded in there for me. I'm like, that sucks. I want to change it. I can't. But they're making it so that you can take it home, plug it in, and it works. And it works great. It really does. And it's like the guest network. On my old system, my network and the guest network were actually on the same network. This new one, nope, totally segmented. It gives it a separate IP scheme, and you can't see you. So it's making it more secure. It's doing it for me, though. That's what I don't like. 'Cause it's like, no, because I always use 192.168.2 because no one has that. I can't use that anymore. So I think now I'm 7. I think it defaults to 7. But okay. So you must come up with a network ID. It's assigning entities and services to the network. Each computer needs an IP address, including the gateway. There's also something called a network ID. Kind of like I live at 8412 Treeline. 8412 is my number on Treeline. Okay. There's also a broadcast, which you cannot assign. Broadcast sends stuff out to everybody. Okay. Running out of time. IPv6. Not quite the same as IPv4. Okay. The problem is we ran out of numbers with IPv4. So we're already switched to IPv6 externally. Like internal real estate is still IPv4. You could actually go to, let's find this website. I think it's Hurricane Electric. Yep, Hurricane Electric. You can go there and get your own personal IPv6 address that you can keep for the rest of your entire life. Pretty nice, because there's that many. There's enough IP addresses to assign one to every blade of grass on the entire planet Earth. It's crazy amounts of addresses that are out there. Okay, it says IPv4 wasn't designed for security, wasn't designed to handle as much as we can. How many devices do you have at your house? I have upwards of 50 now. 50. Yeah. And my lights are on Zigbee, so those don't even count.
Depends on who's at your house.
Yeah, exactly. So it's amazing how many things you have.
Ken, are we gonna cover the extended headers for IPv6 and the idea?
No, we're not. Nope.
Not?
Nope, not in this class.
Okay.
It's not on the exam either. So, all right, overview. We also have binary, octal, and hex. We're almost out of time. Binary is 1s and 0s. Okay, there's tons of videos out there on it. On and off, 1s and 0s. Okay, here's how you can count it. Again, I don't have time to go through this. If you have questions, I can always help you with it. It's not a problem. Nibbles is like portions of it. Rather than reading out that entire number, you can break it up into 2 pieces. And it's easy when converting to hex and octal and stuff like that. Okay, and there's an example of it. Now, octal uses 0 through 7. See, decimal is 0 through 9. Octal is 0 through 7. Hex is 0 through F. Okay, octal it's used a lot for Unix-based systems, like RWX for setting the permissions of your file system. Hexadecimal is 16-bit. Again, I can cover this more again if we need to. And it's actually what's used like with files. We brought up the hex editor. We saw hex, okay, in the other class. So. All right, I think that's pretty much it. We don't need to cover the rest. That's the end of the chapter. So, all right, I'm going to stop the recording, but I'm not here next week. So no one needs to get online next week. The recording for chapter 3 is already up there from last semester. Watch that, do the work, and I will see you the following week. And I did change the due dates. Remember that. I gave you extra time.
You're not going to be at forensics as well?
I will not be at forensics or this class. Yeah, I won't be at either.